So the basic thing that I want to say first off, the first definition of congruent triangles, and you can see it on your screen here, is basically triangles are congruent, okay, if they look the same, okay, exactly the same size, the same shape, the same angles. That means they're the same triangle, okay? So that's exactly what we're going to be looking for. When you have two triangles that have exactly the same length of the sides, okay, and exactly the same angles inside, so that if you were to take one triangle and put it right on top of another triangle, and you were going to look at those and compare them, and they traced exactly the same size and shape, then those two triangles would be congruent, or equal to one another, okay? That's exactly what we're looking at today, and we're going to look at some tools to figure out how to prove that that's the case. So as an example of two triangles that are congruent, let's say you had, okay, a triangle that looked like this, okay? And this point over here is A, and this point up here is B, and this point over here is C, okay? And let's say you had another triangle right here, okay? Looks pretty close. I'm trying to do my best to draw them the same. And this one has D, E, and F. First of all, we say that these triangles are congruent if all of these sides are exactly the same length as these sides, and if all of these corresponding angles, okay, are exactly congruent or equal to one another, okay? So when we say that's the case, we say these two triangles are congruent, and the way you write that down is write the triangle symbol, triangle A, B, C, remember you name triangles by the corners, triangle ABC is congruent to, it's an equal sign with a funny squiggle on top. Basically mathematicians like to have symbols, okay? You already know what the equal sign means. It means two things are equivalent to one another, okay? This equal sign just has a little fancy squiggle on top to remind you that you're not talking about a number. You're not talking about 5 is equal to 10, or 5 is equal to 5, or 7 is equal to 7, or some equation x squared plus 3x equals 7. You're not saying anything like that. You're talking about two shapes. Two shapes, they're equivalent to one another. So it's a little bit different than the mathematical equal sign. This is not an equation we're writing here. We're not writing something we can solve by moving x around, okay? So we have a fancy squiggle on top to remind you it's not exactly an equal sign, but what it's saying is the same thing. These two things are equal, okay? So this triangle ABC is congruent to triangle DEF, okay? DEF. Now, one very important thing that I want to make sure that we say right up front, because this kind of gets a lot of people in trouble, is when you write congruency like this, you have to name the triangle in order, the same order of points. So it's ABC here, so we want to go DEF. So you have to go same order of points. You'll see what I mean as we do some more problems. But basically, when you say these two triangles are congruent, you cannot say triangle ABC is congruent to triangle EDF, even though it's the same triangle, okay? When you're talking about congruency, you should always have your points in exactly the same order, just to keep things straight, okay? So, triangle ABC is congruent to triangle DEF. This means, all this line means, it means a lot of things, so I'm going to write it all out to you. It means that line segment AB, which is this one, is congruent to, can you guess? Line segment DE. This is congruent to this. That's got to be true. BC has got to be congruent to EF. It's got to be true, okay? AC has got to be congruent to DF, okay? It's got to be true. So the three sides are congruent to each other. That's the first thing we already said has to happen. And it also means, because these things are congruent, that angle A, which is the angle inside here, is congruent to angle D. And likewise, angle B is congruent to angle E. And likewise, angle C is congruent to angle F. Okay, so I've written down, and that's kind of why I gave you the pep talk when we first started this thing, to kind of give you the idea that you're going to look at a lot of math here, but really all you're saying are these two triangles the same or not, okay? And the only way they can be is if the three sides are congruent to one another, or equal to one another, okay? And if the three angles are equal. And if those things are met, these triangles are congruent. And breaking it down, this means that the sides are equivalent or congruent and the angles are congruent. Now, if you can prove that, then you know that these two triangles are congruent. So the rest of the section is going to be built upon this fact, or this definition really is what it is, definition of triangle congruency. So we're just going to do some problems that's going to build upon that, and we're also going to have some theorems that are going to help us figure out if triangles are congruent if we don't quite have all of the information, okay? We'll get to that one step at a time. For now, let's work an example because it's always better to learn by examples. First example is, here's a triangle, right? Got obviously three sides of this triangle. This point is R, this point is S, this point is T. And I'm going to draw this triangle kind of in the mirror image here, right? This is G, F, and E. Now, at first glance, you can kind of see that these two triangles may be congruent. In fact, they are going to be congruent, okay? Because I'm working the problem, I know what the answer is. But you can also see that this is kind of a mirror image. I mean, if you put this triangle right on top of this one, it's not going to line up. You're going to have to take and flip this one over, okay? So it doesn't really matter how you turn the triangles or how you flip them. It just matters if they're, no matter how many flips you do and how many rotations, if they line up. So if you can take this one and mentally just sort of flip it over here, I think you can see that it will trace something somewhat of that shape here. So what I want to write down is, if these two triangles are congruent, okay, then the way you would write that is triangle RST is congruent to, and what will you write over here? We obviously know that it's going to be congruent to this triangle. So we went RST here. Do you think we're going to go G, F, and E here? Well, no, because I said that you have to make sure and write your points in the proper order, in the proper orientation. So what you would do here is you would start E and go F and then G. Let's talk about that after I write it on the board. It has to be EFG because what you're doing is, once you line this triangle up on top, which points are going to be first, second, and third? You basically need to look at how you did it in the first triangle. You started over here at this end, you went up, and you went down to the narrow pointy end. So you need to go up and over to the narrow pointy end when you write your letters here. If you put different letters here, it's technically not the right answer, okay, because it has to be done in the same order. So if you're going to prove to yourself that this is the case, then what you're going to need to show is that RS, segment RS, is congruent to which side? It's going to be this side, EF. Okay, EF. And notice here I did R going up to S and I did E going up to F. So I'm doing it in the same order just so that avoid any clarity at all. I mean, any confusion at all. ST, which is this one going down, ST is congruent to FG. So I'm going to write it exactly in that order. FG. I'm going to keep the exact order going down to G. Okay? And then RT is congruent to, RT is going over this way, but remember I flipped things, so I'm going to go E back over to G. And I'm going to say that those are all congruent. And so obviously that's part of it. Now the angles have to be congruent too. So angle S has to be congruent to which angle? Is it this one, or is it, well, it's obviously this one up at the top. Angle S is congruent to angle F, and angle R is going to be congruent with its mirror image, angle E, okay, because these two angles are the ones that have to be equal, because you can see that's the way I've drawn the triangle. And then finally, angle T is congruent, this one here, with this one right here, its mirror image, angle G. So it's the same thing. The sides have to be congruent, the corresponding sides, and the angles have to be congruent, the corresponding angles. We've got a lot of stuff written down here, and it looks really complicated, but when you break it down into terms of what's the fact that the sides and the angles have to be congruent to one another, you look at your triangles, and you kind of try to match up the angles and match up the sides, then you can do that. Okay, now in this part of this section, okay, we've already talked about when two triangles are congruent to one another, that all of the sides have to be congruent and all of the angles also have to be congruent. So if you know the lengths of all of the sides, right, and you know all of the angles, then you can figure out just by using what we learned already before that these two triangles are in fact exactly congruent to one another, exactly equal to one another. Now, there are three postulates, okay, that are going to be in every geometry textbook that you're going to also be able to use to figure out if two triangles are congruent to one another. And the first one's called the side postulate, okay? And you're going to be able to use these a lot to figure out if triangles are congruent. And you can see it on your screen here, but it basically states if the three sides of two triangles are congruent to one another, then the triangles are congruent, okay? Let me say that again. If the three sides of the two triangles that you're looking at are congruent, then the two triangles are automatically congruent. Now, you may say, well, why are you telling me this now? You already told me that the three sides have to be congruent plus the three angles are going to be congruent. And I'm not backing off of that, but I'm saying that this is a simplifying case, okay? All you really need to look at are the three sides of the triangles. And if you can show that the three sides are congruent, then what I'm saying is the three angles inside will automatically be congruent given that the three sides are congruent. So what I said before was true. The three sides of a triangle and the three angles have to be congruent. But here is a theorem or a postulate that tells you that really all you need to look at is the three sides. Because when you do that, the three angles inside will automatically be congruent. So let's look at that. Okay, let's say you had a triangle like this. Okay, we're going to call it ABC because we love to do that. Okay, and here's another triangle right next to it. And we're going to call that D, E, and F because we like to do that. Now, let's say it's given that, let me use a different color just so we can see here. This side is congruent with this side, okay? This side is congruent with this side. Now notice, the one bar is congruent with the one bar. The two bars are congruent with the two bars, so that's very important notation there. And let's say that, given in your problem, that this base here is congruent with this base here, 3 bars and 3 bars. So this is congruent to this, this is congruent to this, this is congruent to this. What the side postulate is telling you is that if you have two triangles that you can show have 3 sides that are congruent to one another, you can put numbers here, 2, 2, 3, 3, 1, 1, whatever, as long as they're the same. The 3 sides being congruent is all you need to really know to be able to prove that these two triangles are congruent. And if you really think about it, if you get your ruler out and figure this out, if you draw a triangle here, okay, if you draw a triangle here like this, let's say, I'm going to give you another little example, and you actually measure this number to be, 4, and you measure this number to be 7, and you measure this number to be, let's say, 6, okay? You've got a unit of 4, a unit of 7, and a unit of, well, that's obviously not going to work. Let's make that an 8, because this is a longer side. 4, 7, and 8, let's say, okay? When you put a ruler up with 4 inches, and then put one at 7 inches, and then put one at 8 inches, when you do that, you have locked in what these angles are, okay? And, I'm not trying to say that they're congruent to one another here. I'm just saying that this angle is defined when you put this here, and you put this at 8, and you put this at 7. You lock what these are in. So if you draw another triangle with the same lengths on the sides, you can do this all day long, but if you make it exactly the same length here, and exactly the same length here, and exactly the same length here, you will, by definition, have locked in the equivalent angles or the corresponding angles. So what I told you initially is exactly true. The 3 sides have to be congruent for the things to be congruent, and the 3 angles are always congruent when you have congruent triangles. What the side postulate is saying is, the angles are automatically defined when you put these two triangles and you prove that they have the equivalent congruent sides. So really all you have to do is look at the sides to use the side postulate. You don't really need to know what the exact angles are, but if the sides are congruent, the triangles are congruent. So as an example, let's look at this. We're going to ask ourselves a question. Are these two triangles congruent? Let's say you had a triangle like this. It goes up, down, and over. A, B, and C. And I have a length of 5, a length of 4, and a length of 3. And then I have another triangle here, okay? And I have D, F, and E. And this length is 4, and this length is 5, and this length is 3. Well, you can see right away that these two triangles are going to be congruent by the side postulate, because this side's congruent with this side's congruent with this side, this side is congruent with this side. So you've shown that all three sides have the same length to their corresponding sides on the other triangle, and that's going to lock in these angles, and it's going to make all of these angles the same as well. And so by the side, side, side postulate, they are congruent. So you will say that these two triangles are congruent, and the reason is because all sides are congruent. So you'll say something like, if you're going to write down your answer, you would say AB is congruent to DF, AB to DF. You would also say that BC is congruent to FE, BC, FE, these are congruent. And you would also say that AC is congruent with DE, AC to DE. And again, I wrote the letters in the proper order because this triangle's flipped as well, so you kind of have to go in the corresponding order. Because the three sides are congruent, what you would write on your paper is you would write this down, you would say all three sides are congruent to their corresponding sides, so these two triangles are congruent by the side, side, side postulate. That's exactly what you would write. So you're using that postulate to figure out that these two triangles are congruent. And notice you didn't have to know anything about these angles. I mean, you don't know what these angles are at all. You're only looking at the sides, and that is why that theorem and the other two theorems coming up are very valuable, because they let you figure out if triangles are congruent without knowing all of the information. You don't have to know all of the angles. You don't have to know all of the sides for some of these other ones that we're going to do in a minute. You just have to know some information. So we've already talked about the side, side, side postulate. Now we're going to talk about the side, angle, side postulate. And we'll draw a picture and make it clear in a second, but it states, and you can see it on your screen here, if two sides and the included angle are congruent between two triangles to the corresponding parts of another triangle, then the triangles are congruent. Okay, so we'll say that one more time. This is called the side, angle, side postulate of triangle congruency, and it says if two sides and the included angle, we'll talk about that in a minute, are congruent to the corresponding parts of another triangle, then the triangles are congruent. Now let's draw a picture of what this means. Let's say you have a triangle looks like this. Okay, we're going to call this point F up here, G and H. Okay, and I'm going to draw what's going to end up being a congruent triangle. Okay, this is going to be P, R, and Q. So I've got two triangles that are obviously congruent, but let's say you don't know the lengths of all these sides, because if you did know the lengths, then you could look at the side, side, side postulate, see if they're all equal, and if they're all equal, they're congruent. But let's say you don't know that information. All you know is that this side is congruent to this side. That's one side. This side is congruent to this side. Whoops, let me put another bar here. So the double bars go together. This side is the same length as this side. The third piece of information is this angle is congruent to this angle, which just means it's the same angle. So you see, now you know why it's called the side, angle, side postulate. This side's congruent, this angle's congruent, and this side is congruent. Side, angle, side. Side, angle, side. That's what it means. So when we say if two sides, these two sides, and the included angle, which is the angle between those two sides, the included angle, if two sides and the included angle are congruent to the corresponding parts of another triangle, then the two triangles are congruent, which means they're the same triangle. Okay. So this would imply, or this would show, I suppose, that triangle FHG is congruent to triangle PRQ. FHG, PRQ. Same order when I write it down. Those two triangles are congruent, and they're congruent by the side, angle, side postulate. Okay, so you can abbreviate it, side, angle, side. You can abbreviate the side, side, side as SSS. You can abbreviate the side, angle, side as SAS. Okay. So as an example of how to apply this, let's take a look at these two triangles and ask ourselves, are they congruent? So here's a triangle. Okay. and this is going to be A, B, C. Here's another triangle, A, B, C. And all I'm told in my problem, okay, is that this length has a unit of 7. This length has a unit of 5. This has a 45-degree angle here at the bottom left. Okay. This has a length of 7. This has a length of 5. And this has a length of 45 degrees. So you cannot use the side, side, side postulate because, yes, this is congruent to this. This is congruent to this. But this one, you really don't know what the length is, so you really can't prove that it's the same, even though it looks like it's the same. But what you do know is that this side and the included angle and the other side are all congruent. Side, angle, side. Side, angle, side. They're all the same. So what you could say is that, yes, they are congruent by the side, angle, side postulate. And what this means, to break it down, is you would say that AB is congruent to DE. You would also say that angle A is congruent to angle, I do my triangle a little bit wrong here. Just to make it clear, we're going to make this D, E, F. Okay. Angle A is congruent to angle D. Okay. And then AC, which is this one here, is congruent to DF. Okay, so what you would do is you would spell it out. This side, AB, is congruent to DE. This angle is congruent to angle D. And AC is congruent to DF. So side, angle, side, by the side, angle, side postulate, yes, these two triangles are congruent. So you would say, your final answer, triangle ABC is congruent to triangle DEF. Okay. All you have to look at is find one side, an included angle, and another side congruent in both triangles, and then you've proven that those two are the same triangle. Okay, now the final postulate that we're going to use is called the angle side angle postulate. So let's not get confused here. We've had the side, 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 which is three sides of the triangles are congruent to the three sides of the other triangle. We have had the side angle side, which is the side, the included angle, and the other side congruent to another triangle. Now we have the angle side angle. Well, let's read that. You can see it on your screen. If two angles and the included side are congruent to the corresponding parts of another triangle, then the triangles are congruent. One more time. If two angles and the included side, we'll talk about that in a minute, are congruent to the corresponding parts of another triangle, then the triangles are congruent. And I think you'll be able to understand this one pretty easily after we after we just covered the last one. So let's say we have a triangle, looks like this. Okay, we're going to call it A, B, C on the points there. Now we have another triangle that we're going to claim is congruent to it. Sure does look similar, right? We're going to call that D, E, and F. But the only thing I know about these two triangles, okay, is that this angle is congruent to this angle. That's what the symbol means here. You put this here, and that means that in these two figures, the two angles are the same. This included side is congruent with this one, with my bar. That's my symbol for congruency there. This angle is congruent to this one. And I'm not going to put a single curve, I'm going to put a double curve, because if I put a single one, I'm going to get confused from this one here. So this one's congruent to this one. So you can see right away, angle, side, angle. This is what we're talking about. ASA, angle, side, angle. Angle, side, angle, angle, side, angle. Congruent, 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 congruent. That's what this postulate says. If I can find an angle, an included side, and another angle that are congruent to the same parts of the other one, then the triangles are by definition congruent. So let's just do a quick example to show what we're talking about here. If you have a triangle that looks like this, okay, A, B, C, this angle, let's say, is 25 degrees. This side has a length of 10, and this angle is 50 degrees, okay? And let's say they draw the other triangle right underneath it, because you know you're going to find out a lot in geometry They're just going to manipulate, they're going to make the drawings look goofy, and that's going to make it hard for you. This length is 10, this angle is 25, and this angle is 50. Okay, so you're looking for proof that these two triangles are exactly the same in every way, shape, and form. And it looks like if you can flip it up that they're going to match, but you have to prove it. So we can't use the side, side, side because I don't even know what two of these sides are. You can't use the side, angle, side because side, angle, side means I need to know two sides and an included angle, but I don't know two sides. But I do see that I have an angle, a side, and an angle. And they're equivalent or congruent to this angle, this included side, and this angle. And that by itself is enough to prove that these two triangles are congruent. And really, when you look at it, if you have this angle here, and you have this length here, and you have this angle here, when you put all that information together and you actually get a ruler out and try to draw these triangles, these three numbers fix the shape of the triangle. That's why they're congruent. You go back and you look at the side, angle, side, same thing. You get two sides and you fix this angle in the middle there, and you're trying to form a triangle with that third side. There's only one way you can do it, and that's why they're congruent. Same thing here. Three numbers, it takes three numbers to define a triangle. That's really the quickest way to look at it. Three sides, two angles in a side, or two sides and an angle. You need three numbers to define a triangle, because a triangle has three sides. So are these two triangles congruent? The answer is yes. By angle, side, angle. And you can use this abbreviation. That's something that's very common. And so to prove it, you would say that angle A is congruent to angle D. Angle A here is congruent to angle D. I didn't bother to even label the triangle here, so let's do this. D, F, and E down here at the bottom. Okay, angle A is congruent to angle D. Line segment AC is congruent to DF. AC to DF. And finally, angle C is congruent to angle F. Angle C is congruent to angle F. So on your paper, you would have to show that this angle side and this angle were congruent. And you would say, yes, these two triangles are congruent. So triangle ABC is congruent. ABC, I got to go in the same order. ABC, DEF. DEF. To triangle DEF. So those two guys are congruent. Okay, so you can see we've done quite a bit in this section, actually. We've defined, a few things that can help us out. We've defined triangle congruency, that all the sides and all the angles have to be the same in order to call two triangles congruent. And we defined three postulates that are going to help you solve problems. So they're actually your friend once you memorize them, because they help save your, save you some time. And that's the side, side, side postulate when all three sides are the same, the side, angle, side, and the angle, side, angle. So, question here for this section, I'm going to put just a few quick drawings on the board. Which postulate would you use to prove that these two triangles are congruent? So these are going to kind of be rapid fire type problems. Okay, you have a triangle looks like this. Okay, you've got another triangle looks like this. Obviously they're congruent. I'm already telling you they're congruent. This side's congruent to this side. This angle is congruent to this angle. This side is congruent to that side. The double bars mean they're congruent to one another. Which postulate would you use? It's not going to be side, 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 okay, because I don't know what this third side is, but I know that I have a side congruent, an angle congruent that's included, and the side congruent here. So it's going to be side, angle, side. That's what I would use to prove that those two things are congruent. Side, angle, side. So what if I had something like, let's see if I can draw this, like this. This is a little bit trickier. All I know is that, and I'll draw it in a different color to help you out here, is that this angle is congruent to this angle. This side is congruent to this side. Now, I've drawn these two triangles point to point. You see, they're going to do that a lot in books, because if you draw the triangle side by side, it's super easy to figure everything out. So they draw it in crazy ways, okay? So this is two triangles pointed together. I've got an angle, and I've got an angle here. I've got an included side, so it looks like I'm headed for angle, side, angle. But I don't really know because I don't know what this angle is. So you might get stumped. I certainly don't know what the lengths of any of these sides are, so I can't use side, side, side. And I can't use side, angle, side, because that's even worse. I only know, I shouldn't say it's worse, but it's equally it doesn't not much help because I don't know, I know that one side's congruent, but I don't know that another side's congruent. So you might stare at this for a long time until you realize that these two lines cross. Okay, and anytime you have two lines that cross, you get a vertical angle. And vertical angles, anytime you have two lines that cross, we talked about this before, that angles here that are opposite of each other, they're called vertical angles, and they're always congruent to one another. So this angle is congruent to that one. That's why I put the double lines there. But in the problem, they won't tell you that right away. You got to figure that out for yourself and remember that from the previous part of the course. So now we can remove the question mark here because now you have angle, side, angle, angle, side, angle. And those are two triangles with corresponding parts that are congruent, angle, side, angle. So that's the postulate you would use. Number 3, let's say you had something like, and again, a lot of times you're going to find that they're just going to draw the triangles in weird ways. Like let's go ahead and flip them over and stick them together and see if that confuses you. Because if you put them side by side, then the problems get too easy. And all they're going to give you is they're going to say this side is congruent with this side, and this side is congruent with this side over here. And you're going to have to figure out which one makes sense. Well, they've given me no angles, none. So I don't really know exactly what to do. And I only have two sides that are congruent to the corresponding parts of the other one. So you might stare at this a while until you realize that this common side here is the same length for both triangles. It's the same length because it shares the same border. So this side is congruent to this side of the same triangle, okay? So what you can use is side, side, side for this one. This one's congruent to this one, this one's congruent to this one, and because this one shares the border, it's obviously, these two sides of the triangle are obviously congruent because they share the same border. So that's an example of something that they wouldn't tell you right away, but something you'd have to figure out on your own. And finally, what if you had a long, slender triangle like this, okay? And I'm going to split it in two. Again, they're going to draw two triangles right up next to each other. The only information they're going to give you in the problem is this side, which is this little base here, is congruent with this little base here, okay? The only other thing they're going to give you is that this is a 90-degree angle. Nothing else is given. And you got to figure out which postulate would you use to prove that this triangle here is congruent to this triangle here. Well, what you have to figure out, well, first of all, what you can do is you notice right away the same trick with this problem. This is a common side. So you can kind of put two little marks here to remind yourself that this side of this triangle is the same as this side of this triangle. So really, I know two sides of these triangles are congruent. So maybe I can use side, side, side. Maybe I can use side, angle, side. Do I have any angle information here? Well, they tell me this is 90 degrees, okay? So side, angle, side, okay? But what would this angle be? Well, then you got to realize that this is a 90-degree angle, okay? And so that automatically means that this also has to be a 90-degree angle. And they didn't tell you that. You just got to know that. Because if this is 90 degrees and this is a straight line, then, in a straight line, a straight angle, this is 90 degrees, this is the other 90 degrees, equals 180 degrees. So anytime you have a straight line, there's 180 degrees there, 90 degrees taken up right here, because that's 90 degrees, and then this is the other 90 degrees. So side, angle, side, side, angle, side. So what you would use would be the side, angle, side postulate to show that. So we've gone over triangle congruency, side, side, side proof of triangle congruency, side, and angle, side, angle. And those are the three core ways that you prove if two triangles are congruent to one another. And when you look at some of these problems, really when you're asked if two triangles are congruent, there's really only a couple ways to figure it out, and we've already talked about what they are. So if you look at a problem and you just scratch your head and you just say, there's not enough information here to solve this problem. Like maybe in this one, you might look and you might say, I don't have enough information. I don't know what the third side is, or I don't know what another angle is. Then what you almost always need to do is look at the problem and and kind of figure out that third piece of information for yourself. Here we had to figure out that this angle was 90 degrees because this one was 90 degrees. And this is a shared side, so the two sides are congruent there. Same trick there. This was a vertical angle. We had to figure out a third angle there. Okay, so anytime you stare at a problem and you just say, I don't know where to start, I don't have enough information, try to figure out what that third piece of information is by what you know and by what they've given you. And that's how you do triangle congruency in geometry.
Learn anything at mathandscience.com.